So Pythagoras theorem states that given a right-angled triangle, the triangle must be right-angled, and you have said that triangle has 3 sides. Given a right-angled triangle, it says the square of the longest side is equals to the sum of the squares of the 2 shorter sides. In other words, it says if this side is A, one of the shorter side is A, and another shorter side is B in length, and the longer side is C in length, it says A squared, which is the length of one of the shorter sides, plus B squared, which is the other length of a shorter side, will give us C squared, which is the square of the length of the longer side. And this can be proved by we have just, this is the right angle triangle, ABC. If we say A squared, that is like saying A multiplied by A, which will give us a square, or the area of the square. So the area of this square is A times A, which will be A squared. If we elongate so that we have a square with the side C and C, then the area of this square here will be C squared. And if this is B, then this measurement here is also B. That means the area of this square is B squared. So then Pythagoras theorem states that A squared plus B squared is equals to C squared. In other words, it says the area, this A squared, this is A squared, this area plus this area, it will be equal to this area. How can we prove this theory, the Pythagoras theorem? So we have a larger square outside, and then we have another smaller square inside. So that let's look at how to calculate the area of the square inside. Of measuring length is C. So the area of the square inside is given by C times C, which is C squared. What about the area of this larger square outside that is measuring A and B? So we are told from here to here the length is A, and from here to here the length is B. So if we are supposed to get the length from this point to this point, what do we say? We say A plus B. So the length from this side, from this end to this end, will be measuring A plus B. It will be the same case with this other side of this bigger square. From here to here, that will be A plus B also. So the length is A plus B, and the base is also measuring A plus B. Area So the area of the outside or the largest square is A plus B squared. A plus B squared. If we try to open the brackets, that will give us A squared plus 2AB plus B squared. That is the area of the larger square. We want to find the area of the triangles. The area of the triangles, of the 4 triangles here. The area of the 4 triangles. So that we would say the area of the inside square. We want to prove or to determine if really, if we find the area of the bigger square, then subtract the area of the triangles here, we'll be able to find the area of the inside square. So what is the area of the rectangle? We have 4 rectangles, and you see that all of them are measuring A and by B. From our last lesson, we learned that area of the triangle is half base times height. If we substitute in our formula, realize that A this is the area of one triangle, but we have 4 triangles, so we multiply the area by 4. The area of the 4 triangles is 2A, 2 times A times B. So we realize that the area of the larger rectangle is A squared plus 2AB plus B squared. So for us to be able to calculate the area of the smaller square, we say the area of the bigger square minus the area of the triangles. A squared plus 2ab plus b squared minus the area of the triangles, which is 2ab. Let us put together the like terms. And the like terms is which one? You realize that we have a squared plus b squared plus 2ab minus 2ab. So because this is this and this is 2ab minus 2ab, that will be equal to 0. Then what do we have? The area of the inside square, the smaller square, is equals to a squared plus b. And from our dimensions here, which is c, and c we had earlier calculated and realized that the area of the inside square is c squared. From our calculation using a and b, the area of the inside square is a squared plus b squared. From using the dimensions of c, the area of the smaller square is c squared. So what do we have? The Pythagoras theorem. A squared plus b squared is equals to c squared. And this again are the sides of a right angle triangle. The sides of a right angle triangle. So let us understand a right angle triangle. We have the longest side of a right angle triangle, and it is called hypotenuse. Hypotenuse refers to the longest side of the right angle triangle, and it is opposite the right angle. It is opposite the right angle. This is hypotenuse and this is the right angle. So they are opposite. The right angle and the hypotenuse are opposites to each other. That means we have the three sides of a triangle, which normally appear as a set of three whole numbers. Set of three whole numbers, that is the sides of a right angle triangle, are called Pythagorean Triad. Pythagorean Triad are a set of three whole numbers that represent the three sides of a right angle triangle. For example, in our case, A, B, C is what we are referring to as a Pythagorean triad. Given three whole numbers, a set of three whole numbers, how do you know that this make up a Pythagorean triad? In other words, do they make the three sides of a right angle triangle? How do you know if they are three sides of a right angle triangle? For example, decide if the following are Pythagorean triad. 6, 8, 10. How do you go about it? We will use the Pythagoras Theorem, which states that the squares of the sum of the squares of the two shorter sides of a right angle triangle is equals to the square of the longest side of the right angle triangle. In other words, for you to be able to know that this is a set of a Pythagorean triad, they must fulfill this equation, that a squared plus b squared should be equal to c squared. So we have said the hypotenuse refers to the longest side of the triangle. That means the longest side is c. So the two shorter sides will be taken by 6 and 8, and the longest side will be the hypotenuse. Always, in a triad, given the three sets of whole numbers, the longest side will be the hypotenuse, which is represented by c. So we substitute these values in this formula. 6 squared plus 8 squared should give us 10 squared. Let us see if that will be true. 6 squared is equal to 36. 8 squared, that will be equal to 64. Let us add 36 and 64. That will give us 100. 100 is the same as 10 squared. So that means 6 squared plus 8 squared is equals to 10 squared, which is right. If that is the case, then this means that the three numbers, or the three whole numbers, are Pythagorean triad. Let's see if these three are they a Pythagorean triad or not. Again, what do? We use the formula a squared plus b squared will give us c squared. Let's substitute these values into this equation. And remember, always the longest side is the hypotenuse, which is represented by letter C. So 9 will come after the equal sign. So let us see if these values will agree. 4 squared, that will be 16. 5 squared, that will give us 25. 9 squared, supposed to give us 81. So let's see if we add 16 plus 25, it will give us 81. So if we add 16 and 25, it's not giving us 81. So they are not equal. 41 and 81 are not equal, meaning this is not a Pythagorean triad. That is not a Pythagorean triad. So given a set of three whole numbers, and you are told to determine if it is a Pythagorean triad, meaning they make the three sides of a right angle triangle, you are supposed to substitute in the formula. A squared plus b squared, which should give us c squared. If it will not give us c squared, if you add a squared and b squared and it does not equal to c squared, then that is not a Pythagorean triad. We can also use the Pythagoras theorem to decide or determine if an angle is a right angle triangle, or if a triangle is a right angle triangle. Because we have said the three sides of a right angle triangle agrees with the formula a squared plus b squared is equals to c squared. Determine if the triangle below has a right angle. By just looking at this triangle, you cannot be able to know whether it's a right angle. So for us to be able to know whether it's a right angle, what do we do? Again, we use the Pythagoras theorem, which states that the sum of the squares of the two shorter sides of a right angle should be equal to the square of the longer side, or the hypotenuse. Let's see if this triangle here will satisfy the Pythagoras theorem. So we have said, given a set of three numbers, the longest is the hypotenuse, and that is represented by C. So our hypotenuse will be 9. These others are 4, and the other shorter side is 7. So if we calculate 4 squared, that will be 16. 7 squared, 49. 9 squared, that should be 81. Let's add these two and see if it will give us 81. That will be 65. 65 is not equal to 81. That means this triangle here does not have a right angle. It does not have a right angle, because if it has a right angle, then it is supposed to satisfy the Pythagoras theorem, a squared plus b squared equals to c squared. That is how we determine if it has a right angle or not. So when we have the Pythagoras theorem, that means we have a right angle triangle. Then you have two sides which are known and one side is unknown. How do you go about it? Pythagoras theorem again will help us to be able to identify or to determine the other side of a triangle that is unknown. For example, Find the length of the hypotenuse of these right angle triangles. So we have a right angle triangle that is measuring 6 by 8, and the hypotenuse, the longest side of the triangle, is unknown. How do we go about finding the length of the hypotenuse? Again, the Pythagoras theorem, which states that a squared plus b squared is equals to c squared, will be of much help to us here. How? Because we know the two shorter sides of the right angle triangle. What is missing is the longest side. We substitute in the formula. And we have our equation now. 6 squared plus 8 squared will give us c squared. Because we only have one unknown, we can be able to calculate and find the unknown. So 6 squared, that will give us 36. 8 squared, 64. If we add the 2, that should give us c squared. 36 plus 64, we know that will be 100. So what this statement means is that c squared is 100, equal to 100. But our hypotenuse is measuring c. Our hypotenuse is c. But our 100 here is c squared. So how do we go about getting c? We find the square root. We find the square root of both sides. If we find the square root of this side, then we must also find the square root of this other side. The square root of c squared, that will give us c. The square root of 100, that is 10. So that means c is equals to 10. The value of c is 10. We know that if we find the square root of any value, then the answer is either positive or negative, that value. But because we are dealing with length here, length is not negative, so we take the positive. So then our c is 10. Find the length of the hypotenuse of this triangle. How do we go about it again? You realize we are saying we will use the Pythagoras theorem. A squared plus b squared is equals to c squared. Then you substitute. We have the two shorter sides. We say the longer side is c. We substitute a with 7 and b with 9, we'll get the equation. So 7 squared, that is 49. 9 squared, we have 81, and that should give us c squared. If we add the two, 49 and 81, that will be equal to 130, which is our c squared. Again, for us to be able to find c from c squared, we find the square root. We find the square root, and the square root of both sides. These should be the both sides. That will give us c, and this will give us 11.40. That is to 2 decimal places. So the length of the hypotenuse here is 11.40. 11.40. Or or we leave it at that? This is a third. We can leave it at this point. This is a third. A third is a number that has a square root sign. It is written in its simplest form. In its simplest form, it has a square root sign. A third cannot be written as a fraction, and it cannot be written also, or if you want to write it in a decimal, then you will find so many numbers after the decimal with no repeated pattern. In other words, we are saying you will have so many decimals forever. That's a third. So there are some numbers which we can write it and leave it in a third form. Other examples of thirds are 2, square root of 2. If you press in your calculator the square root of 2, you realize that that will give us and it continues. You realize that there is no numbers are repeated. There is no repeated pattern. So you'll continue writing the decimals forever. So these numbers here are called thirds. So now that we know how to calculate the longest side, if it is missing, the length of the longer side is missing, we can be able to use the hypotenuse. Now let's use the hypotenuse to find, or let's use the Pythagoras theorem to find the perimeter given two sides of a triangle and the other one is missing. We have a triangle measuring 2 meters by 3 meters. You're told to find the perimeter of the triangle. So the perimeter of the triangle, we know that from our last lesson, the previous lesson, we learned that perimeter is the distance all round the outside of the shape. So the distance all round is perimeter. But we are given, this is 2 meters, this is 3 meters. This side is not known. How do you go about finding the perimeter? The first thing that you need to do is to find the distance or the length of the side that is missing. And to be able to do that, we use Pythagoras Theorem. A squared plus b squared will give us c squared. So when we find the square of 2 and 3, that will give us 4 plus 9, and that is 13. The square root of 13 This is another one that is also a side, 3.6, 3.60, that is to 2 decimal places. .61. So now we have the side that is missing 3.61. Then now we can be able to find the perimeter. So that is in meters. That will give us 8.61 meters. 8.61 meters. Let's look at another example. So again, we have a side that is missing. We have, this side is 18, this is 10 centimeters, but this side is also missing. But we are asked to find the perimeter. So we have said the first thing is to calculate the length of the longest side. Using the formula a squared plus b squared, that will give us c squared. So if we substitute in our equation, then we have 10 squared plus 18 squared. That will be giving us the value of c squared. 10 squared is 100. 18 squared, that will give us 324. If we add them, that will amount to c squared. So if we add this and this, we have 424, which is c squared. To find c, we calculate the square root of c squared and that will give us 20.59 as the value of c. That is equal to 2 decimal places. This is also another side. You can leave it at this because you will have so many decimal places continuously. So now that we know c is 20.59, then we can be able to find the perimeter now of this triangle. And we have said the perimeter is the distance all round. The distance all round, we add all the 3 sides of the triangle. So the perimeter of this triangle will be 48.59 centimeters. That is the perimeter. So we can be able to use the knowledge on Pythagoras Theorem to find the perimeter of a triangle whose one side is also missing, whose hypotenuse is missing. So given a triangle, the hypotenuse is missing, or the length of the hypotenuse is missing, you are supposed to use the Pythagoras Theorem, substitute in the formula, find the square root, and you'll find the side that is missing. Then now you can be able to add the distance all round. So we have looked at how to calculate or determine the length of the hypotenuse, and we have said hypotenuse is the longest side of a right angle triangle. Supposing one of the shorter side of the right angle triangle, the length is missing. You are asked to determine the length of we have a triangle. This is A. Triangle A, and this is 5, this is 4. We are told to find the length of the shorter side. That is A. A is unknown. Again, we still use the formula. This time round, the longest side, which is the hypotenuse, is known. So we will substitute the known values. The hypotenuse is 5, so that will be equal to 5 squared. So we have A squared plus 4 squared is equals to 25 squared. So we'll calculate the square of 4, that will be 16. And we'll also find out the square of 5. 5 squared, that will be 25. Then we collect the like terms. We collect the like terms. So 16 and 25. So we minus 16 this other side and minus on the other side. So we find that A squared will be 9. For us to be able to find the value of A, we find the square root. We find the square root of A, and we find the square root of A, we must also find the square root of the value after the equal sign. What is the square root of 9? That will give us 3. So our A is equals to 3. Our A is equals to 3. So when you're finding the length of the shorter side, you are also supposed to write the equation, then substitute the values that are known, and be able to calculate the values that are not known. So this time round, we know A, we know C, B is unknown. You're told to determine the length of B. So we will still use our formula. A squared plus B squared will give us C squared. So our A is 9, B not known, our C is 15. So if we calculate B, 9 is 81 squared, 9 squared is 81, plus B squared, 15 squared, that is 225. Then now we look or put together the like terms so that we remain here with B. We subtract 81 from this other side and subtract 81 the other side so that we remain, we don't want 81 here, we want to take it to the other side. So we subtract 81 here, we'll also subtract after the equal sign. So this one cancels out. We have 50b squared remaining alone on this side. 225 minus 81, that will give us that will give us 144. B squared is 144. Again, we have to find the value of B. So to remove the square, we find the square root. If you find the square root on this other side, then you also must find the square root here. The square root of B, we know, is 12. The square root of B is equals to 12. So again, you realize that any side of the triangle any side of a right angle triangle that is measuring A, B, and C. If there is any side that is unknown, then we substitute in our values. A squared plus B squared is equals to C squared. So we substitute the known values in the equation, A squared plus B squared, which is given equal to C squared. Then we can now be able to find the unknown value. So we can use the Pythagoras theorem to find any side of a right angle triangle that is unknown. So let's look at the application of Pythagoras theorem. Given a question, a 10-meter steel brace holds up a concrete wall. The bottom of the brace is 5 meters from the base of the wall. Find the height of the concrete wall, correct to 2 decimal places. So the first thing that you are supposed to understand is how to come up with a right angle triangle. How to put these measurements in a right angle triangle. So we are told a 10-meter steel brace holds up a concrete wall. So we have a concrete wall. Concrete wall that is 10 meters high. Then we have the brace. And we are told, so we have the wall. Note this is this length of the brace. The brace is 10 meters. Then the bottom of the brace is 5 meters from the base of the wall. From the wall to the bottom of the brace, it is 5 meters. So the question is, find the height of the concrete wall, correct to 2 decimal places. So what do? a question of this nature, you need to, because you realize this is a right-angled triangle, we'll apply the Pythagoras Theorem. Which side is unknown? We are told to find the height of the concrete wall. You realize that the concrete wall here is one of the shorter sides of the right-angled triangle. So 10 meters is the longest side. So the length of the wall is what is missing, that is represented by A. So again, five squared is 25, 10 squared is 100. So then we look, we put together, collect the like terms. If we subtract 25 from this side, we remain with A squared. We subtract 25 the other side, we remain with A squared is equals to 75. So for us to be able to calculate the value of A, we find the square root. Again, this is a third. Correct to 2 decimal places. 8.66. So the length of the wall is 8.66 meters. 8.66 meters. So we are able to solve this problem using Pythagoras. So let's look at this other problem. For a 14 centimeters drinking straw just fits into a can as shown below in the diagram. The diameter of the can is 7 centimeters. Find the height of the can correct to decimal places. How do we go about solving this problem? So you realize the can, the straw, and the bottom of the can. So the straw forms the hypotenuse. The diameter of the bottom side of the can is what is forming the other side of the triangle, and the side of the can is forming the other side of the triangle. So we can be able to see that the can is 14 centimeters in hypotenuse. It is 7 centimeters in diameter, which forms, the diameter forms the other shorter side of the can. Then the other side that is missing is the side of the can. We are told to find the height of the can. So we can represent it that way. When we put it that way, then we can be able to calculate the side of that can. The side of that can by using the Pythagoras theorem, a squared plus b squared, which will be equal to c squared. So our a squared b side is not known, our hypotenuse is known, that will be about 14 squared. So let's find the squares. 7 squared, that is 49. 14 squared, $196. Let us subtract 49 from both sides. So 49 minus 49, that will be equal to 0. So we remain with b squared half here. (196 minus 49), and that will be equal to 147. For us to be able to find the value of b, we find the square root. And square root, we have said both sides. So the square root of 147 12.12 to 2 decimal places. That is now the height of the can. So the height of the can is 12.12 centimeters. So you can see that we are able to use the Pythagoras theorem to solve problems involving lengths. So today we have learned about Pythagoras theorem, and we have said it states that the sum of the squares of the two shorter sides of a right angle triangle is equals to the square of the hypotenuse. And we have seen how a Pythagoras theorem can be proved, and also how it can be used to solve real life problems. Thank you.